is estimating mu with a small sample size. And by small sample size, that means that it's less than 30. 8.1 was estimating mu with a sample size of 30 or more. So on your notes, you're going to see at 8.2, there's really a nice table here that relates 8.1 and 8.2. But there are primarily one big difference, and that is that you're going to be using a new table. We're finally going to be moving away from the Z table, the normal distribution table, and going to a T table called the students table, students distribution table. So what that really means is that in 8.1 with the large sample size, or greater than or equal to 30, we estimated our Z value by, which is a standard deviation value, and we said that we're going to remember it by writing it as in terms of the zone. And this value here is the standard deviation. It's the standard deviation for the sample size. So you could write it as S, but I think it just makes it a little bit easier if you just continue to write it as your little signal. So now what we're going to do is we're actually going to be going from that to something called a tone. And so instead of a Z, we're going to have a T. And therefore, that's how we're going to determine the error. And this T, the T value, is going to be found by a different table. And this is the small sample size. So the next thing that we want to know is basically what's this new table look like and how do I use it? And so I'm going to just talk a little bit about that, and then we're going to go fill out this worksheet, and within about 7 to 10 minutes we'll be done here. So the new table is showing you that it says students T distribution, and it's in your packet. And the only things that you're going to be referencing is this DF, which stands for degrees of freedom, and we'll talk about that in a little bit, and the C value, which is your confidence value. For example, 90% confident, 95% confident. Do not worry at all about these alpha, prime, and double prime. We're just going to be looking at the confidence level up here and the degree of frequency, and from that you'll be able to find out what your T value is, which is in the middle of the table. All right. Now, the question is, what is this degree of freedom? The degree of freedom, which is going to be one of two main things that you can get goofed up in this section, is it's n-1. That's all it is. So we're going to go to the worksheet, and we're going to see that the degree of freedom, which is right here, is equal to n-1, degree of freedom. And this is what you're going to use in the table, as you saw. Pretty soon you're going to have a lot more freedom in a couple weeks, hopefully. So good timing on that. Let's go look at the other ideas and find these T values. Instead of finding Z values, you're finding the T values. That's it. So find the critical value, T sub C, for 99 confidence level, or 99%, for a t-distribution of sample size n equals 5. And so in a problem like this, the first thing you're going to do is write down the degree of freedom is equal to n minus 1, which equals 5 minus 1, or 4. You're going to write that down so you don't mix it up. And then what you're going to do is go to the table, and remember it's 99. When you go to the table, here's your 99 in the last column, and you're looking at 4, so it's 4.604. And that's going to be the t-value that you're going to use instead of the z-value. 4.604. So that means that's all it's asking for. Please go ahead and try to find it for the next one. Looking at your DF as 8 and your confidence level of 90%, you're going to see it's equal to 1.860. And then you would go ahead and use that. Now, we're going to apply that to a story problem and try to make some sense of this. And we're basically talking about large artificial sapphires. And as you skim through the problem, you're going to see that in a trial run, 12 sapphires are produced. 12 is the sample size. So this 12 means n is equal to 12. I'm going to write that down. And then it says the x bar is going to be 6.75. That's the same x bar that we used before when I found my confidence interval. Same idea. This sample standard deviation, I'm going to say, is just my little sigma, and that's 0.33. The question is, what is the confidence interval, just like we did before? What is your approximation for your population mean, given that you're talking about 95%? So the first thing we do is find the degrees of freedom. That's going to be 12 minus 1 and 11. Then I'm going to go to the table, and I'm going to look at 11 and where it crosses with 0.95 to find my t-value, and the t-value turns out to be 2.201. Then I want to find my E. When I see E, I'm thinking the zone or the tone here. In this case, it's the tone because it's a sample size less than 30. So I'm going to remember that the air, well, I can say tone is equal to the air. So then I just want to substitute in 2.201 times 0.33 divided by the square root of, now be careful on this one. This is the other possibility of mistake. One possibility of mistake was not subtracting 1 to find your degrees of freedom. The other possibility of mistake is this is over the square root of n. It's the original n that I'm using, so it should be over 12, square root of 12. So that is going to tell me that I'm going to get 0.21. Find the confidence interval. Just like before, we had my mu approximation is going to be my my x bar minus my error and my x bar plus my error. So that means my x bar in the problem is 6.75. Therefore, the confidence interval is going to be between these two numbers. Now, that means with 95% certainty, your approximation for your population mean is going to be between 6.54 and 6.95 carats. Now, the last question is just one more point that we didn't cover, and it says, what assumption are you making about the distribution? And the assumption in this section is that your population is approximately normal. By using your T table, you have to assume that you're dealing with an approximately normal population, because it's not going to say it. The other times it said the population is normal. But when you're dealing with such a small sample size, you have to make that assumption. So the assumption is the population is approximately normal. Everything else is the same. You can see that this is kind of a little stretch from the last section, and that will conclude the stats unit. We're going to cover one last unit, which is probability, and do some review problems, and then we have the district final. You should be working on your summary sheet. That's that one page. I would get your notes and start writing everything that you wrote down and highlighted off of the notes.